Welcome to video 6. We're talking about the multiple bonds that actually exist in the bonds that we have in molecules. Here we go. In covalent bonds, the bonds actually result from the overlapping of orbitals. So a single covalent bond is this. Okay, and actually the electrons are typically found in these clouds, and now they're really found together, and basically the fact that they're now being, like, these electrons are being pulled to both atoms holds them together. And we'll talk about what happens with double and triple covalent bonds, but they result from overlapping. They're not just a line somehow holding between them. Every covalent bond has one what we call sigma bond. Now, this is just the simple overlap of orbitals like I just showed you. They're directly between the atoms and typically a strong bond, but it's really not all that rigid. So this is where you've got like a Venn diagram overlap. Okay, it doesn't quite look like a Venn diagram, but it's the easiest way to imagine it. They're held together, but they're not all that rigid. You can kind of rotate this around a little bit, and they'll stay together, but you can kind of bend it a bit. So every covalent bond has one sigma bond. Okay? Any bond stronger than a single bond, because remember that single is a sigma, results from more overlapping of orbitals. Here's the issue though. The space directly between the orbitals is a sigma bond. The nuclei. This should have been nuclei. So the space right between the two nuclei is already covered, which means if we've got nucleus and nucleus, we can't really go between these anymore. We can't add more overlap because they're already overlapping. So we have to somehow go around, or like kind of in different planes, if you will, to actually make this bond stronger. So this kind of sideways overlapping of orbitals, these are called pi bonds, like the number. These bonds in themselves are actually weaker than sigma bonds, because remember, sigma is directly between the nuclei. Pi's are kind of overlapping around each other, if you will. This is like, instead of nailing two pieces of board together, you put a little bit of duct tape around them. Now, the duct tape itself is strong, but if you're going to attach wood together, you nail it, or screw it, or put a bolt or something through it. You don't just add tape. However, if the nail really isn't all that strong, tape's very useful to kind of hold it together a little bit better. Like, together, they're super strong. But just by themselves, tape's not all that great an idea. So, overall, like I said, they make the connection a little bit more rigid and firm, if you will. So, here's a summary of what I just said. If we have a single bond, we have a sigma. More so, every type of bond, including quadruple, which really doesn't happen all that much, but has one sigma bond. Anything higher has a pi bond. And you'll notice that a single is 1 plus 0 for 1. 1 plus 1 is 2, double. 1 plus 2, 3, triple. 1 plus 3 is 4, quadruple. So that's really all it comes down to. We have one bond right between them, and anything stronger just starts overlapping around the sides. So, how many pi, sigma, and pi bonds are in the CH3CN molecule? Well, take a bit, draw that molecule, get an idea of the bonds. Well, before that, pause this video, and I'll come back with the answer. Alright, so here's the molecule. I'm going to kind of count you through them, just to really show what you're saying. We have one sigma bond. So sigma bonds, we have 1, 2, 3, 4, 5. 5 sigma. Pi bonds, we don't have any over here because these are all sigma. The other 2 in this, so out of these 3, one of them is sigma and the other 2 are pi bonds. That's it. That covers multiple bonds, gives you a better idea of how covalent bonds work. Thanks for watching.